In the diagram shown below, PA is a tangent to circle T at point A, and secant PBC is drawn where point B is on circle T. If PB is equal to 3, BC is 15, what is the length of PA? So the length of PA, I'm going to call that x. So in order for us to solve this problem, you have to know the circle theorem involving the lengths of secants and tangents. So let me just quickly remind you of what that theorem was. So the theorem states that if you have a secant and the length of the portion of the secant that extends outside of the circle, let's call that A. Let's call the overall length of the secant there B. The product of these two segments, the one that's outside and the overall length of the secant, will equal to, let's call the length of the tangent there, T, will equal to the tangent squared. So this relationship can be shown through similar triangle proofs, but I'm not going to do that in this video. But I highly encourage you to maybe pause and try to convince yourself why that's the case, to go through the derivation. And if you can't do that, look into the lessons involving the lengths of secants and tangents, where I do go through the proof in detail. Anyway, so looking at this right now, if I apply this theorem to this problem, I can then say 3 times the full length of the secant, which is 15 plus 3, will equal to the length of the tangent, which I'm calling x, just x squared. So if I go through the simplification here, 3 times 15 plus 3, that's 3 times 18 is equal to x squared. 3 times 18, that's 54, is equal to x squared. And then we're going to take the square root of both sides. X is equal to the square root of 54. And the square root of 54 is equivalent to square root of 9 times 6. So therefore, x is equal to 3 square root of 6. And that would be option 2.